gradient descent.
Hello. Hi, everyone. I'm Jingfeng, currently a postdoc researcher at Simon's Institute. Today, I'm gonna share about some interesting but simple theory about gradient descent. So, gradient descent is a one of the fundamental algorithm to find the minimizer of some loss function, and it's especially important in machine learning and deep learning. So I hope everyone have heard about gradient descent a little bit. So if you haven't heard about it, the formula is very simple, as shown in this equation. It says that to find the minimizer of a loss function, I should walk towards the negative gradient direction. Okay, but okay, the idea is simple, but how much update should I make at every step? That is, how should I choose the step size or learning rate in gradient descent? To answer this question, let's first check what the classical optimization theory tells us about this. So the idea is as follows. Let's insert the gradient descent update back to our function, and let's do a second order Taylor expansion and group the first order term and the second order term. Then we see that, okay, if the step size eta is small enough, then this green box must be positive. That guarantees that I can decrease the loss function value by a little bit after performing one gradient descent update. Okay, this is very nice. And you can also verify this idea by doing a quadratic loss example. So you can precisely track the function value update at every step. Okay, these observations are very nice. Let's summarize what we have seen so far. This is also known as the descent lemma. So if we do a small step size, if we do gradient descent with a small step size, then the loss function induced by gradient descent is guaranteed to decrease monotonically. Okay. And if you run gradient descent with a large step size, GD, the function value might diverge. For example, in this quadratic function case. Okay, this is very nice. But what happens if we run some experiment in deep learning setup? So this plot it's for learning a 3-layer neural network for a 10-class classification problem, and I'm using gradient descent with a constant step size. So we see that okay, now when I use a small step size, I can minimize the training loss. This is expected from the descent lemma, but we also see that when I use a large step size, I can also decrease the training loss. However, this time, the training loss is decreasing in a non-monotonic manner. And the latter phenomenon is known as the edge of stability. And I would like to emphasize that the edge of stability cannot be explained by the classical optimization theory, because you see the training loss is really oscillating. So it fundamentally violates the descent lemma. Good. So what happens for gradient descent with a large step size? So in a recent paper, we proved that for gradient descent, if we in the neural network training, if we simplify the problem a little bit, let's say the model is linear and the data set can be perfectly separated, then gradient descent with any constant step size still can minimize the training loss. And I can do a quick proof by picture, and I'm gonna end with a open problem. So what's the benefit of the large step size over the small step size? So that's all I have. Thank you.
Thanks a lot, Jingfeng. Any questions?
Is the answer to the open question, is it about rate? Like how fast rate is it?
the rate, asymptotic rate, you can show in this problem the asymptotic rate is the same. So the benefit comes in finite time.
Great. Well, thanks again.